to teach us how to loop like a native. Please give him a warm welcome.
Thank you very much. So my name is Ned Batchelder. I'm not going to tell you who I am. You can Google me if you're interested. Let's get into the meat of the talk. If this talk is too long and you didn't listen, here's the summary. Iteration is in all of your programs. Python has very powerful tools for iteration. You can be very direct about your iteration. I'm going to show you examples of being weird about your iteration, and you should stop doing that. And you should write more abstractions. We're used to having functions that abstract series of statements and classes that abstract bundles of data with methods to work on them. Python also has tools for abstracting the iteration that we use, and I'm going to show you some examples of how to do that. This talk is labeled as a beginner talk because I start from the very beginning, but it actually gets into more advanced material. I prefer to think of it not less as a beginner talk than as a fundamentals talk. And I think if there are experts who've wandered in here by mistake, please stay. I think you'll find something useful. So let's talk about iteration basics. This is an example of a loop. Let's say you have a list. You want to iterate over all the values in the list and print out all the values. You can start a counter at 0. You can loop as long as the counter is still within the range of the list. You can get the element out of the list. You can print that value, and then you can increment I to go on to the next element so that you can go back to the while loop and it continues around and around. This is how most programmers are taught to loop initially because it uses the simplest tools available in the language, and it's available in any programming language. Python programmers know you shouldn't do this. If you want to loop over all of the indexes of a list, you can use the range function. Range of len of my list will give you an I that ranges from 0 to 1 minus the length of the list. You can get the element out of the list, and you can print it. But both of these ways are really Rube Goldberg's, right? We started with the problem of, I want to print the elements in my list, and the first thing we do is we go and we start talking about integers. I don't care about integers. What has that got to do with the problem at hand, right? We might as well have said the boot kicks the football, which goes into the net and tips the watering can over, right? So what you should really be doing if you want to loop over the elements in your list is you should use a for loop and just loop over the elements in the list. For v in my list, print v. No integers, right? We haven't gotten distracted by some side issue about how lists are implemented. We can simply loop over the list directly. The for loop is a very basic statement in Python. It's very powerful. The iterable value produces a stream of values, and we'll talk later about exactly what an iterable is. But an iterable is something that can produce a stream of values. It assigns each stream value to the name, and then it executes the statements once for each value in the iterable. And the iterable gets to decide what values it produces. This is a key point. And lots of different things are iterable. So the for loop will execute the statements once for every value in the stream produced by the iterable. But the iterable itself gets to decide what those values are. And Python has a lot of different kinds of iterables. So for instance, if you iterate a list, it gives you its elements. If you iterate a string, it gives you its characters. If you iterate a dictionary, you get its keys, which is a little counterintuitive. People often focus on the values in a dictionary, but a dictionary is really best thought of as a collection of keys, each of which gives you its values, which is why for K and D gives you all the keys, and if K and D asks if a key is in the dictionary. Notice that it gives them to you in a surprising order. And also down here, the dictionary has other methods if you want to iterate over different things. So if you want to iterate over the values, there's a method on the dictionary to get a stream of the values, and you can also get a stream of the items, the key value pairs out of the dictionary. So this is an interesting example because notice that a dictionary is not a linear thing. There is no order to a dictionary, but when you iterate over it, it gives things to you in an order. Files, you can iterate them and it gives you their lines. And this is very handy because if you want to open a text file and do something once for each line in the file, you don't have to use .readline in a while loop. You can simply iterate over the file directly. So once we've opened the file as f, we can use for line in f, and that will assign to line a string which is each line in the file in turn. So we get the first line, and then the second line, and then the third line. The standard library has lots of other interesting iterables as well. So for instance, in the RE module, there's find iter, which will give you a stream of match objects, one for each place in the string where your pattern is matched. The os.walk function iterates all of the subdirectories in a tree of directories. This is interesting because we've taken a fundamentally two-dimensional structure, a tree of subdirectories, and we've flattened it out by iterating over the subdirectories. os.walk has kind of a strange form. You see it gives you 3 values each time. The point here is that os.walk produces an iterable, and the for loop can iterate over it. Iteratools is a module which is full of all sorts of tools for playing with iteration. The count function gives you an infinite stream of integers, starting with 0, and it just keeps going forever. It never stops. So probably here you want to have some way of ending this loop. But the important thing to note is that an iterable can be an indefinite iterable. There's no way to ask an iterable, how many values do you have? And that's a great thing that it doesn't give you that ability, because that lets us have infinite iterables. And lastly, the iteratools module has all sorts of cool functions that you can use to put things together. Here, I've made a chain which repeats 17 3 times and then cycles forever around all of the values in range of 4, which gives me 17, 17, 17, 1, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 forever. I'm not sure why you'd use that, but iteratools gives you these pieces to build these pipelines together to make interesting iteration. Right? And the point here is not so much that you need to memorize what's in iteratools, because you can't. Every time you think you have an iteration problem, you don't know how to solve it, look in iteratools, it's in there somewhere. No one knows everything that's in there. That's fine, don't feel bad. The point is that Python gives you a way of creating iterables, which are streams of values, and they can take all sorts of forms. And a point I'm going to make to you over the course of this talk is that your code has interesting streams of values that you are not producing in a nice iterable form yet, and you should. In addition to the standard library giving you interesting iterables, Python has other things to do with iterables. So you can iterate over them with the for loop, but for instance, the list function will take an iterable and will pull all the values out of it and give you a list of all of them. Don't use this on iteratools.count, because you will run out of time. A list comprehension can loop over an iterable and give you, for example, all of the values f of x for every x in your iterable. Sum will take an iterable full of things that can be added together and give you the total of all of them. Min and max will take you iterables of comparable values, like numbers or strings, and find you the least or greatest value. And join will take an iterable of strings and join them all together. And this is just a few examples of all of the different places in Python where you can use an iterable, where you can loop over your data without having an explicit loop. Right? The list comprehension actually says for in it, so it looks kind of like a loop, but none of the others do. The loop is implicit in the function. So an iterable not only is something that you can construct to build your values the way you want, but you can pass them into functions. Those functions can do things with them. They can return new iterables to you, and so on and so forth. Let's talk about some common questions. So when we were looping over our list, we got rid of the integers, right? We're no longer looping from 0 up to n-1. And the integer lovers out there who really wanted to use that form find a lot of ways to come back and say, okay, you were right about that case, but I've got another case where I really need to use those integers. So I'm going to go back to using integers. And the first example is, I also want the index, right? So I want to loop over everything in my list, but I also want to know, is this the 0th one? Is this the 17th one? Is this the 233rd one? And often what they do is they resort to using for I in range of len of my list. And I'm going to assert right now that anytime you see range of len of something, you don't need it. You probably is a better way to do it. So here we can use for I in range of len of my list, we can pull the value out of our list, and then we can print both the index and the value, right? We've solved the problem. How can I print out all of the values with their index? But this is not the way to do it. The way to do it is that Python gives you an enumerate function. And enumerate will give you two values for every value you give it. It'll give you the index and the original value. So here, if I have a list of landmarks with the Eiffel Tower, Empire State, and Sears Tower, if I enumerate those names and make a list of what enumerate gives me, you can see that I've gotten a tuple of 0, Eiffel Tower, and 1, Empire State, and 2, Sears Tower. So enumerate has taken an iterable, and it pulls values off of the iterable, and bundles them together with the index. It's keeping track of how many it's gotten, and it gives you pairs that are the index and the value, right? So now we can do the right thing to number our values without resorting to integers, right? We're still focused on the actual thing we care about iterating, which is the values out of the list, but we can also then annotate them with the numbers. Right, so we get the output that we want. Okay, the integer lovers, all right, I really miss my integers, but I can see that you've got that case covered. Oh, sorry, one other thing about for I in range of len of list. A problem with this is that this step here, my list sub I, only works if the value you're iterating can be indexed. Right, lists can be iterated over, but you can also ask for the 17th element. Lots of iterables don't let you do that. So when we use enumerate of an iterable, we don't have to index into the list. For example, an open file object, you can't get the 100th line in a file by saying f sub 100. You have to read them in order. Right? So if we wanted to read all the lines in a file with their numbers, we couldn't use the range of len of list trick. Enumerate does it for us, and it does it better because it's less code. We're not talking about integers, and so on and so forth. By the way, here's the other bad way, which is you use a for loop, but you also keep an integer alongside, right? This is just dumb. Don't do this. You don't need silly sidecars on your code. Like, why is that little I running alongside like a puppy next to your data, right? Stay focused on what you're trying to do here, right? You can write simpler code that is better. Okay, so the integer lovers, they'll grant us this, but okay, now I've got two lists, right? I've got a list of the names of my landmarks and their heights in meters, and I want to print out the correspondence between them, right? So now I have to go back to my integers, right? I can go back to my integers, please? So you use for I in range of len of names, and then you can get the name out of the names list and the height out of the heights list, and you can do what you want. We still don't have to do this. The answer is that there's a function called zip. Zip takes a pair of streams and gives you a stream of pairs. So what zip produces is a list of pairs where each pair is the first element out of the two iterables you gave it. The next value is the two values out of the iterables you gave it. The third value is all the third values out of the iterables you gave it, and so on and so forth. So here we've got less code, right? If you look at the previous slide, we had 4 lines of code in our for loop, and we were distracted by all this, name sub I and height sub I. Here we've got less code, and we're more direct. We're not distracted by integers anymore. So again, zip is a function that takes iterables and produces an iterable, right? We don't just have static data that we're looping over. We can take an iterable as a value and manipulate it in a function to produce a new value, which is itself an iterable. Very powerful. And by the way, just as another example of where Python does interesting things with iterables, the dict constructor will take a stream of pairs, which means if we have a list, which is the names of our landmarks, and a list of their heights, dict of zip of names and heights will give us a dictionary mapping the names to the heights. Because the zip gives us a stream of pairs, dict takes a stream of pairs and makes a dictionary out of them. So we're manipulating data in very powerful ways by constructing iterables and consuming iterables. Now let's say that we've built that dictionary. We've got a dictionary called tall buildings, which is all of these buildings with their heights. There's various ways that we can manipulate this. For instance, the max function can tell us what is the tallest value. We know that the tallest building is 828 meters. The max of the items, if we sort them by their second element, is the Burj Khalifa, which is 828. And if we just look at we sort the keys based on their values, then we get the Burj Khalifa out, the name. And all of this just goes to show you that Python gives you the ability to loop tall buildings in a single bound. That joke's the whole reason I'm giving this talk. Okay, let's talk about customizing iteration. So we've seen that Python gives you very powerful ways of dealing with data, dealing with serialized data in a stream. We can also customize it to be even more direct. So let's say that we've got a list of numbers called nums. And what we want to do is we want to do something for all of the even values in our list. Right? The simple thing to do is that we can just simply iterate over our numbers, and for the even ones, this will test to see if it's even, we'll do something. And this is fine, this is a really short loop, but imagine that the actual condition we were looking for is much more complicated. And so it's actually a number of lines of code, for example. We might want to separate that loop out. This loop, to me, is doing two things. It's picking values out of the list, and then it's doing something with the values. And the picking and the doing can be two separate pieces that can be abstracted apart. So for instance, what we could do is we could define a function called evens, which accepts a stream of values. And it makes an empty list, and for all of the values in the stream, it puts the even ones into our list, and then it returns the list. So now what we've got is a function called evens, which accepts an iterable and produces a new iterable, which happens to be a list, but it's iterable. And that means that now we can say for n in evens of num, do something. So we've successfully separated them, right? The evens function encapsulates which are the things we want to do, things to, and then the loop actually has the something we want to do. So we've separated them. This is abstracting our iteration, right? We've written a function that takes a stream and makes a new stream, which is just what we want. The way we made that is not so great, and those of you who have dealt with generators before probably thought, why isn't he using a generator? So what's a generator? A generator is like a function. A function, when you call it, it runs all the statements and it returns one value. A generator, when you call it, produces an iterator, and when you iterate the values in the iterator, it runs the statements in the generator, and every time it hits a yield statement, it produces one more value. So it's kind of like a function that can keep producing values over and over again. And for instance here, we've defined hello world. This is a very simple generator. You'd never see this in the real world. It simply has two statements. First, it yields hello, and then it yields world. And in fact, if you loop over that for x and hello world, print x will get run twice, once to print hello and once to print world, because the generator made an iterable which, when you ask it for values, will give you hello, and then it will give you world, and then it will tell you that it's done. So generators are a really, really powerful way to implement iteration. And if you take nothing else from this, well, you're going to take the Superman joke from this joke, but after that, if you only take two things from this talk, you should be writing more generators. And if you don't know what generators are, and this confuses you because it's kind of weird, and by the way, if you're coming from other programming languages and you're learning Python, generators are the first place where you think, oh, it's not just a syntax change. This actually is executing very differently than I'm used to. So I understand if it's a little bit complex and a little bit foreign. Look into it. You'll be really glad. So let's look at how we can use a generator to make our evens function. So here's the same evens function, but we've turned it into a generator. And it was very simple. All we did is we got rid of the initialization of the empty list. We still have the same loop over the stream. We still do the same comparison, but then instead of appending to our list, we just yield the value. And then we can get rid of the return list at the end. So the generator is actually much simpler than what people think of as the simpler thing, which is to make a list. And then we can use for n and evens of num and do the things we want to do. Great thing about generator is it's lazy. For instance, that first evens function, if we passed it an infinite stream, it would compute until the end of time trying to produce that list of all the even values, right? Evens of itertools.count would never complete. But you can do evens of itertools.count with a generator because all it does is it executes its statements until it finds something and then it yields a value. So it would return 0 to you, and then it would return 2 to you, and then it would return 4 to you. Evens doesn't care that the stream it's got is infinite, right? If you give it an infinite stream, it will be an infinite stream, but that's fine because the generator is producing values as you need them rather than chunking them all up at once. By the way, if you look in Python 2, range is a function that returns a list of all the numbers. Xrange is a generator that produces the list of numbers as you need them. Range of 100 quintillion will run out of space. X range of 100 quintillion will run out of time. That's how you can keep them straight. Now, as another example of abstracting your iteration, here we've got a more complex and more realistic example of the same problem with the evens. Right? With evens, we were looping over stuff, picking the ones we want, and then doing things with it. Here, we're reading a text file. But the text file has a format where it can have blank lines or it can have commented lines, and we don't want to look at those lines. We're going to skip over those lines and only do something with the interesting lines. So we open our file, we loop over it, we strip the white space. If it starts with pound, then we're going to continue, meaning we're not going to end up getting down to the do something line. If the line is actually blank after stripping it, meaning it was a blank line, then we're going to continue. If we make it through that gauntlet of tests, then we'll get down to our do something. So the interesting lines will get down to here and we'll do something. But again, this loop is doing two things. It's filtering out the values that we want to work on, and it's actually doing the thing. So just like we did with evens, we're going to make a generator for it. So we're going to take all of that logic that we had at the top. It looks exactly the same. But at the end, we're simply going to yield the interesting lines. So now we have a function called interesting lines, which can take us an iterable. I said we took a file, but notice we don't do anything here that knows that it's a file. This is one of the great points of Python's polymorphic duck typing. This function will take any value that can produce strings, which means that we can test this function in our unit tests using lists of strings. So we have file processing that we can test without having any files, which is amazing. So this is another good reason to abstract your iteration. The piece you get out, once you've pulled it out, will probably be more testable and more applicable to more kinds of data than you had started with. Once we've got the generator, then we can use it. So we can say for line and interesting lines of f. And this kind of processing of lines and skipping the comments and the blank lines is the kind of thing that will probably come up in your programs many times. And so you've saved the logic and moved it into a generator where you've got it in just one place and you can test it and not worry about it so much. So this is a great example of abstracting the iteration. Right? You've taken what seemed like a simple task, open a file, look at some lines, do something with just some of them. But instead of having the explicit conditions right there in the main line of your code, you've moved it into an abstraction that gives you a stream over interesting lines in the file rather than a stream of all the lines in the file. And this is what I mean about your data is probably something that you can make abstractions of iterations for. Okay, another question from the integer levers. Sorry, where are the iterator levers? The bad guys are the integer levers. How do you break out of two loops? Let's say you've got a spreadsheet. right? And you're searching through the cells of a spreadsheet for something. We all know how to do a search through the cells of a spreadsheet. You have two loops, right? You loop over the rows, and then you loop over the columns, and then you get the value out, and then you can do something with it, and then if this is the value you want to stop the loop. There's no way to break out of two nested loops in Python, right? And the typical answers are, well, you put the inner loop into a function so you can return, or you use a try except block. Those are all the wrong answers. The answer is that you make it a single loop. So instead of having a double loop over the rows and columns, we can make a generator that produces pairs of numbers. It's a 2D range. So we say we want all the coordinates in a grid that goes from width to height. And so we've got our double loop in our it generator, and we yield the pairs. And now we can have a single loop that loops over our spreadsheet, right? And so now the answer is easy. We have a break. So not only have we gotten rid of the integers, right, much to the chagrin of the integer lovers, but we've got simpler code that we can actually do more with, which is fabulous. Now, of course, this is still kind of silly because we're still sort of talking about integers because column and row is coming out of there. The right answer is that a spreadsheet should have a method on it called cells, which gives you all the cells. And the fact that it's a 2D spreadsheet or a 3D spreadsheet, why do you know that at this level? You just want to get all the cells out of the spreadsheet. And once you've got that, then you can still have your single loop. Let's talk a little about low-level iteration and how you can customize your objects. What's actually happening at the lower level, I've been using the terms iterable and iterator. And people often think they're interchangeable. They're not. An iterable is any value that can produce a stream of values. And an iterator is the object that knows where you are in that stream. You can think of it like a book full of pages is an iterable, and the bookmark is the iterator. An interesting point about that is you can have two bookmarks in the same book. And the way it works is that an iterable produces its iterator by being called on the iter function. So the iter function will take an iterable and produce an iterator, and then the iterator, you can use the next function to just do next, next, next to get values off of the iterator. And that's the only operation that's supported on iterators. You can't ask what the last value was, you can't ask what the next value was, you can't ask is there a next value, you can't ask how many values there are going to be, you can't say please give me back this value the next time I ask you for a value. You can't do any of that stuff. All you can say is give me the next value. And that simplicity is the power of iterables because it's promising so little, it's applicable to as broadest set of data as possible. Lots of different things can be iterable because you don't need to know much about the data to iterate it. As an interesting example of using low-level iteration, let's say you have a text file that's got a CSV file maybe, and it's got a header line, and then it's got all the data lines. So you want to read one line off the file, and then read the rest. You can use the next function directly on your open file, and it will give you the first line as a string. And then when you loop over the rest of the file, it'll give you all the rest of the lines. So you can use next to customize, just pick one value off of an iterator, and then the next time you iterate over all of it, it picks up from where it's pointing to and brings you all the rest. How do you make your own objects iterable? So going back to, for instance, the spreadsheet case, right? It had a cells method on it. We're going to make a to-do list here. We're not really going to make it. It's got almost no code in it. But let's say we have a self.tasks attribute, which is a list, and it's going to be a list of these task objects. The way you make an object iterable is you implement the dunder_iter method. And when someone calls iter of your to-do list, it will invoke the dunder_iter method, and the dunder_iter method has to return an iterator. And the simplest way to return an iterator is to use the iter function on some data that you've got. So if we have self.tasks, which is a list, iter of self.tasks is an iterator over that list, and now our object is iterable because we've got a dunder_iter method that returns an iterator. And I know, you're getting all scrambled about iterator and iterable, and it'll probably sort itself out as you work through this. Once we've done that, we can construct a to-do list, and now we can say for task in to-do. If we hadn't implemented dunder_iter and you tried to do that, it would say that it is not an iterable object. But now it is, right? So we've made our own object iterable directly. So we don't need to know that there's a task list in there and loop over the task list. We can just loop over the to-do list. And by the way, dunder_iter is a great place to put generators. Remember I said a generator is a function that when you call it produces an iterator. And then 10 minutes later I said dunder_iter is a method on your object that when you call it has to produce an iterator. Which means dunder_iter is a really good place to use generators. So here, for instance, we've changed our to-do list so that when we iterate over it, we're going to look through all the tasks, and only if the task is not done will we return it. So iterating the to-do list directly gives you all of the not yet done tasks. And we've added another method called all, which gives us all of the tasks, which we know how to do. We just did it on the last slide. Iter of self.tasks will give us an iterator over our tasks list. And by the way, here's another cool thing which I don't have time to explain, which is called a generator expression. This does the same kind of logic that our dunder-iter method does, but in one expression. And it produces a generator without actually implementing a whole function for it. So once you've got the hang of generators, remember that generator expressions look just like list comprehensions, but they work like generators, so that they're lazy and they only produce things when they need to. Wrapping it up. Thank you for getting that joke. Iteration is everywhere, right? There's very little chance that any of you are writing real programs that don't have to iterate over data somewhere. Python has a very clean and powerful model for iteration that's used throughout the standard library, but isn't as widely used throughout our own code. We're not writing enough generators and dunder-iter methods. So abstract and customize your iterations. And if you do, you will have superpowers too. Thank you.
We have about 5 minutes for questions. If you'd like to ask a question, please line. Oh, that's really bright. Please line up behind the mic there and ask.
Hi, Matt. Your mic's off.
Hey, Ned. Great talk. One nitpick, you mentioned that X range is a generator.
I know it's not a generator, it's an object that is an iterator, I know. Okay.
So yeah, you can iterate over a generator multiple times. You can't do that on a generator. You can also slice it.
You just blew it, because you said you could iterate over generator multiple times. Sorry. You may iterate over X range multiple times.
I twisted.
Don't snipe at me, dude.
Turnabout is fair play. Anyone else?
Anyone else? No? That means I could have left in 3 slides. I won't do it to you. I do it to Matt. Matt and I are good friends. That's okay.
Can you talk a little bit about the stop iteration?
Yeah. So what I didn't mention was that when you call next of an iterable, it will produce you a next value. Except if there is no next value, then it will raise an exception. That's how the end of the iteration is indicated in that low-level iterable protocol. And that's a great thing because that means that any Python value at all can be an element of an iteration. Right? You can have an iteration that produces none, 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 0, 0, 0, false, false, false. And there's a special thing that indicates the end, which is the stop iteration exception that gets raised. So for example, in that code where I used next on the file, technically, if I use an empty file here, I'll actually get a stop iteration exception when I try that because there is no next value. So you might have to watch out for that if you're using the next function. It turns out the next function also has a second optional argument, which is the value to return if there actually isn't another value. So you can avoid the stop iteration if you're doing that.
So I've seen some code where they are modifying the list as they're iterating over it.
Yes.
And what they usually do is have an integer iterate over the list backwards and remove elements. Would you recommend instead creating a new list? Or?
It's usually much better to just make a new list. So the question is about iterating over a list and modifying the list as you do it. And for instance, if you have a list and you're going to examine elements and you want to get rid of those elements and you delete them from the list, if you do that going forwards, then the iterator thinks you're on the 4th element, you remove the 4th element, a new element comes down to be the 4th element, and then the iterator goes to the 5th element and you've completely skipped this element, right? Because you're modifying the list as the iterator is pointing at it. One way that people solve that is they just do it backwards. They go from the end, deleting things, and then they don't have to worry because the iterator is going back that way. But really, the better way is just to make a whole new list, right? Instead of deleting the ones you don't want, make a new list which is all the ones you do want, and then you don't get into that trouble. And other things have the same problem. If you modify a dictionary while you're iterating it, you'll actually get an exception, because the dictionary machinery can tell that you've done that, and it knows that your program is not going to work right. Because you can't predict the order of elements in a dictionary, so you can't even, psych it out and do it backwards to fix it. So you get an exception in that case.
Thanks.
Anyone else?
I won't snipe at you, I promise. No?
Thank you, sir.
Go forth.
To teach us how to loop like a native, please give him a warm welcome.
Thank you very much. So my name is Ned Batchelder. I'm not going to tell you who I am. You can Google me if you're interested. Let's get into the meat of the talk. If this talk is too long and you didn't listen, here's the summary. Iteration is in all of your programs. Python has very powerful tools for iteration. You can be very direct about your iteration. I'm going to show you examples of being weird about your iteration, and you should stop doing that. And you should write more abstractions. We're used to having functions that abstract series of statements and classes that abstract bundles of data with methods to work on them. Python also has tools for abstracting the iteration that we use, and I'm going to show you some examples of how to do that. This talk is labeled as a beginner talk because I start from the very beginning, but it actually gets into more advanced material. I prefer to think of a list. You can get the element out of the list, and you can print it. But both of these ways are really Rube Goldberg's, right? We started with the problem of, I want to print the elements of my list, and the first thing we do is we go and we start talking about integers. I don't care about integers. What has that got to do with the problem at hand, right? We might as well have said, the boot kicks the football, which goes into the net and tips the watering can over, right? So what you should really be doing if you want to loop over the elements in your list is you should use a for loop and just loop over the elements in the list. For v in my list, print v. No integers, right? We haven't gotten distracted by some side issue about how lists are implemented. We can simply loop over the list directly. The for loop is a very basic statement in Python. It's very powerful. The iterable value produces a stream of values, and we'll talk later about exactly what an iterable is. But an iterable is something that can produce a stream of values. Think of it not less as a beginner talk than as a fundamentals talk. And I think if there are experts who've wandered in here by mistake, please stay. I think you'll find something useful. So let's talk about iteration basics. This is an example of a loop. Let's say you have a list. You want to iterate over all the values in the list and print out all the values. You can start a counter at 0. You can loop as long as the counter is still within the range of the list. You can get the element out of the list. You can print that value, and then you can increment I to go on to the next element so that you can go back to the while loop and it continues around and around. This is how most programmers are taught to loop initially because it uses the simplest tools available in the language, and it's available in any programming language. Python programmers know you shouldn't do this. If you want to loop over all of the indexes of a list, you can use the range function. Range of len of my list will give you an I that ranges from 0 to 1 minus the length of the list. It assigns each stream value to the name, and then it executes the statements once for each value in the iterable. And the iterable gets to decide what values it produces. This is a key point. And lots of different things are iterable. So the for loop will execute the statements once for every value in the stream produced by the iterable. But the iterable itself gets to decide what those values are. And Python has a lot of different kinds of iterables. So for instance, if you iterate a list, it gives you its elements. If you iterate a string, it gives you its characters. If you iterate a dictionary, you get its keys, which is a little counterintuitive. People often focus on the values in a dictionary, but a dictionary is really best thought of as a collection of keys, each of which gives you its values, which is why for K and D gives you all the keys, and if K and D asks if a key is in the dictionary. Notice that it gives them to you in a surprising order. And also down here, the dictionary has other methods if you want to iterate over different things. So if you want to iterate over the values, there's a method on the dictionary to get a stream of the values, and you can also get a stream of the items, the key value pairs out of the dictionary. So this is an interesting example because notice that a dictionary is not a linear thing. There is no order to a dictionary, but when you iterate over it, it gives things to you in an order. Files, you can iterate them and it gives you their lines. And this is very handy because if you want to open a text file and do something once for each line in the file, you don't have to use .readline in a while loop. You can simply iterate over the file directly. So once we've opened the file as f, we can use for line in f, and that will assign to line a string which is each line in the file in turn. So we get the first line, and then the second line, and then the third line. The standard library has lots of other interesting iterables as well. So for instance, in the